Let's take a look at arc length for polar curves. To do this, we're going to use the parametric form that we've looked at before. So, if x is r cosine theta, and remember r is a function of theta, so we need to think of r as actually being r of theta. So if I take the derivative with respect to theta, dx d theta, I need the product rule. So I will have r prime cosine of theta minus r sine theta. And likewise for y equals r sine theta, dy d theta will be r prime sine theta plus r cosine theta. So now I just want to take a look at what this means under the radical. So what I'm going to have is dx d theta. Remember we did parametric form, we thought of it in terms of t, but now we have a function of theta. So what I need is dx d theta squared plus dy d theta squared. Well, that's going to be r prime cosine of theta minus r sine theta, quantity squared, plus r prime sine theta plus r cosine theta, quantity squared. So if I square that, I will have r prime squared cosine theta squared minus 2 r prime r cosine theta sine theta plus r squared sine of theta. Plus, that took care of this first piece, plus the second piece, which is going to give me r prime squared sine squared of theta plus 2 r prime r sine of theta cosine theta plus r squared cosine squared theta. That took care of this second piece. Now, you know, with all these sines and cosines and squaring these things, you know this has got to simplify somehow. That's just the way the math gods would have done this. And the first thing that I'm seeing is this negative here and this positive here. That will cancel out. Now, in terms of canceling things out, I don't see anything else I can cancel out, but I am noticing that I have an r prime squared cosine squared and an r prime squared sine squared. That makes sense to put those together, because when I do, and I factor out the r prime squared, I'll get r prime squared times cosine squared theta plus sine squared theta. And oops, I just noticed here this is supposed to be squared. Okay, well that's nice because this is just 1. And see, that took care of that. And over here, well, that was that one. So now I'm going to take this one and this one. See, I just combined these two. So now I'm going to do the same thing combining these two. And I will get plus r squared times cosine squared theta plus sine squared theta. Of course, that goes to 1, or that is equal to 1. So what I end up with, this whole thing is equal to simply r prime squared plus r squared. Well, that's kind of nice, because that's telling me that the arc length is going to equal the integral from theta 1 to theta 2 of the square root of, remember r is a function of theta, so r of theta prime squared plus r squared theta d theta. So that's what we can use to actually calculate the arc length using polar coordinates. So let's take a look at this example. I'm going to find the arc length of r equals 5 times 1 plus cosine theta. So I need r prime of theta. So r prime of theta will be, well actually let's rewrite r of theta real quickly first. Let me erase that. I'm going to rewrite r of theta quickly to be 5 plus 5 cosine of theta. That would then be, or imply that r prime of theta equals negative 5 sine theta. So what I need is the arc length S will be equal to the integral from theta 1 to theta 2 of the square root of r prime of theta, quantity squared, plus r of theta, quantity squared, d theta, which in this case is going to be equal to the integral. And I'm going to go from 0 to pi rather than 2 pi. The reason being is I'm going to use symmetry. This side is the same as the other side. So I'm just simply going to take twice that amount and go from 0 to pi. That's going to be the square root of negative 5 sine theta squared plus r of theta, which I'm going to leave right now as 5 times 1 plus cosine of theta, that entire piece squared, d theta. Okay, so obviously I need to take a look at this and do a little bit of algebra before I can start taking integrals. So this is going to be equal to 2 times the integral from 0 to pi square root. This will give me 25 sine squared theta plus, if I square this, I'll have 25 times 1 plus 2 cosine theta plus cosine squared theta. That's that squared times this squared. Of course, I need the square root of all of this, d theta. So obviously, the reason I did that is I'm going to factor out this 25. So when I do, it's going to come out as a 5. And then 5 times 2 is 10, so I will have 10 times the integral from 0 to pi, square root of, let me see, sine squared theta, plus, I'm going to change the order here a little bit, cosine squared theta, plus 1 plus 2 cosine theta. Now the reason I changed the order is because, once again, sine squared plus cosine squared is 1. 1 plus 1 is 2. So this is really equal to 10 times the integral from 0 to pi, square root of 2 plus 2 cosine theta, d theta. Now I'm going to make one more adjustment here. I'm going to factor out this 2. So this is going to be square root of 2 times 10 times the integral from 0 to pi, square root of 1 plus cosine theta, d theta. Now I need to integrate this, and to integrate this, I'm going to do a little bit more algebra. Remember, right now we are at, let's see, 10 root 2 times the integral from 0 to pi, square root of 1 plus cosine theta, d theta. So I'm going to work with this a little bit. I'm going to take the square root of 1 plus cosine theta over 1. I'm going to multiply it by the square root of 1 minus cosine theta over the square root of 1 minus cosine theta. I'm just multiplying by 1. And the object here, or the idea here, is to get this into a form that I can actually work with. Well, when I do that, I'm going to have the square root of 1 minus cosine squared theta divided by the square root of 1 minus cosine theta. Well, 1 minus cosine squared is sine squared. Square root of sine squared is sine. So I can write this as sine of theta over square root of 1 minus cosine of theta. Well, that's really nice, because now I can do a straight u substitution and integrate this. So where am I? I am at, let's see, let's do it here. I'm going to have 10 root 2 times the integral 0 to pi of sine theta over the square root of 1 minus cosine theta d theta. So if I let u equal 1 minus cosine theta, then du equals sine theta d theta. Exactly what I need here. So I can evaluate this thing as 10 root 2 times the integral of u to the negative 1/2 du, which now that is easy to find an antiderivative of. That is going to be equal to 10 root 2 times u to the 1/2 over 1/2. Correct? I'm just adding 1. So this is going to be 20 root 2, oops, 20 root 2, because of this 2 right here, times u to the 1/2. Well, that's going to be the square root of 1 minus cosine of theta, evaluated from 0 to pi. So what do I end up with? This is going to be equal to, let's come over here, I'm going to have 20 root 2 multiplied by, see at pi, I'm going to have 1 minus a negative 1, so that's 1 plus 1, that's 2. So this could be root 2. Minus, at 0, I have 1. Cosine of 0 is 1. 1 minus 1 is 0, so this is just simply 0. So this is going to be 20 times root 2 squared, that's 20 times 2, that's 40. So the total arc length is 40 units. That's it.